Good evening. My name is Elliot Tigantani.
And my name is Jasmine Wood. We are from the University of South Florida in Tampa, presenting our project, Sustainable Energy and Water Control at 7 Wetlands. As representatives of the firm Alley & Craw, we hope you enjoy learning about our journey in designing a solution for a vital environmental site of our regional community. Our project site, the 7 Wetlands Park, is located in the state of Florida in the United States of America. Within Florida, the 7 Wetlands Park is 25 miles southeast of Tampa in the city of Lakeland, Polk County. The area served by 7 Wetlands was once a phosphate mine that was later converted into wetlands in the mid-1980s. The park has recently been enjoyed as a recreational area open to the public since 2018, with plans of greater public park access in the next 1 to 2 years. There are also plans in place for an educational center to be built. For the city of Lakeland, the 7 Wetlands is unique because it functions as a tertiary treatment or final polishing facility for a majority of the county's treated wastewater. It also functions as a wildlife and conservation habitat for many different endangered species. And finally, it's a public city park. These wetlands constitute an area of about 1,600 acres, and they're divided into 7 individual cells. Within these cells, there are 11 different control structures controlling the water flow. The influent treated wastewater, equaling about 10 million gallons per day, comes from 2 sources. 91% of it comes from the Glendale Wastewater Treatment Plant, and the remainder comes from the Polk County Regional Wastewater Treatment Plant. Once the treated wastewater makes its way through all of the cells, 5 million gallons per day goes into the Tico Polk County Power Station. If the total suspended solids level is low enough, some water is then discharged into the Alafia River. As we continue our presentation, you will find that the basis of our project is on upgrading current park technology in order to provide a more efficient facility to the park staff, as well as to provide a cleaner environment to the local wildlife and public visitors. As mentioned earlier, there are 11 control structures presently found at 7 Wetlands, all of which contain manually operated gates. With all of the structures being over 30 years old, they are deteriorating and reaching the end of their service lives. Thus, these control structures require replacement very soon. In times of inclement weather, the park staff has very difficult time operating these gates. So our goal with this project is to assess the current infrastructure and gate infrastructure, and to determine exactly how to upgrade this infrastructure to integrate it into an automated system. With limited access to power at the park, we had to look at alternative and innovative ways to enable electrical power for gate automation. In addition, 7 Wetlands Park is proud to be a recreational area for the public to enjoy. Because of this, there's a huge emphasis on educating the public about the park's wildlife and natural wetland processes that are occurring 24/7, with the park potentially building an educational center and increasing the areas the public has access to in the near future. They want to increase education by identifying more ways for educating visitors.
As said before, there are 11 existing control structures, all being over 30 years old. These control structures are controlling exactly how much water goes into the next wetland cell. They're entirely made from concrete and built with a rectangular weir. The water flows directly from the cell's water level into a concrete rectangular box, dropping anywhere from 7 to 15 feet, leading into the next cell. For the control structures, we found the best solutions would be to refurbish the structures or replace them in full. The existing gates attached to each control structure are manual stop log gates. To control water through these gates, stop logs have to be added or removed manually, with each one changing the amount of water that is allowed to flow through. This gate design is causing multiple issues for the park staff. With inclement weather, there may be times where water storage in any certain cell may need to be changed. This creates a situation basically where a park staff member may be putting themselves at risk, even not allowing for any immediate change in water levels. With the goal being to create an automated system, we found there are 3 different gate designs we could implement: vertical lift gate, slide gate, or a dual leaf gate.
Within the next few years, the park has a goal of building a 2-story on-site educational center specifically within Cell 3. Cell 3 is currently heavily forested and far away from any power source. So this creates a challenge in powering the educational center that will be built in the future. Throughout the park, there are a few kiosks displaying park information with different educational points for visitors. With the implementation of new structures, gates, and power sources, there is an opportunity to provide enriched educational experiences for guests. Because the majority of the park is off the power grid, the most suitable way to generate power is through a renewable energy source. 3 energy alternatives most suitable for this project are hydroelectric energy, wind turbines, and solar panels.
For us to find a solution efficiently, we aim to determine exactly which criteria are most vital to our client and to the beneficiaries of this project. Because the Seven Wetlands Park is a natural and protected site, the constructability of our solution must have a minimal impact. In order to preserve wildlife and create a safer environment for the public, any solution must be sustainable and clean. In order to reduce the number of repairs needed, the solution must be reliable in terms of the products used and in terms of how we design the project. So keeping in mind a minimal impact is needed, any solution must be easily accessed and easily repairable if needed. Last, the solution must be economically sound over the design life of the project.
By utilizing the evaluation criteria that Elliot just described, Ali and Craw tabulated a decision matrix on all possible control structure, gate, and renewable energy alternatives. Refurbishing the existing control structures was not considered because the control structures are irregularly shaped in size, making it difficult for new gates to be installed within each control structure, and plus the gates are at an advanced age. Thus, we elected to outright replace the control structures. With respect to the gate alternatives, the dual leaf gate structure was selected over the other alternatives due to 2 reasons. First, the dual leaf gate allows for a more favorable use of space due to its compact design. And second, the dual leaf gate minimizes disturbance of surrounding water levels and wetland soil conditions. Finally, with respect to the renewable energy alternatives, hydroelectric power requires sufficient elevation head in order for there to be enough energy to be generated inside the turbines. And unfortunately, such head is not found in the Seven Wetlands flow train. Moreover, wind turbines pose a threat to avian species. And aside from that, wind turbines are known for their low reliability due to the fact that ample wind conditions in Florida are not typically available. So finally, solar panels were selected particularly for their high reliability and serviceability qualities. And this is suited for the local sunny conditions in Central Florida, which allow for a significant generation of electricity since a majority of sunny days are found throughout the calendar year. Ali and Craw's proposed solution includes a 4-step process. First, 4 control structures will be designed and built. Following that, the fully automated dual leaf gates will be fitted onto the 4 control structures. Next, we will install remote monitoring equipment to allow for an increase in more accurate data collection. Elliot will later discuss this. Finally, a manufacturer will design and install solar panels and the associated storage equipment to generate and store energy for the automated gates and future educational center.
The proposed control structures will be built with the proposed gates in mind. In order to fit all of the power and automation needs, the top platform of the structures will be widened. This will allow for easy access for work vehicles and for moving any equipment needed. To replace the existing stop block gates, we're proposing to install dual leaf gates. They're designed with 2 gates side by side to each other. Because there are 2 gates, they can be maneuvered in numerous ways, allowing for several different ways to control the water flow, and they create a more efficient use of space, making the gate work very well as an automated system. In order to validate our design, to find out if the newly designed control structures and gates will affect the existing grade line of the wetlands, we calculated the flow of water through each cell in order to find the grade line between each structure. In doing so, it was found that there would be no adverse effects to the wetlands. To allow for an increased and more accurate data collection for the park, we're proposing to add a water level monitor, water flow monitor, and a total suspended solids monitor at each control structure of interest. This will allow for the park staff to react to any water management issue that may arise. A total suspended solids monitor was chosen because this is a wetland's biggest issue in terms of water quality. Currently, there is no continuous data collection of any kind. For ease of use of all new equipment, including the gate automation and monitoring systems, there will be a base station installed within the park's maintenance building, which is where all automation and data can be accessed.
The existing educational kiosk will be upgraded, and along with that, there will be new kiosks installed to serve as an educational opportunity for informing guests of the benefits of the renewable energy that is being provided to the park. These kiosks will include a real-time energy output at each automated gate, as well as an interactive model showing the inner components of a solar cell. To power the automated gates and monitoring systems attached to each control structure, we are proposing the use of a Panasonic HIT N325 solar panel. This is an upgraded version of the already existing solar panels found at the park today. By installing the upgraded version, this will minimize any hours that will be needed to train staff on the operation and maintenance of the solar panels. In order to store the energy the panels transferred, there will be a shed built at each gate site to hold battery storage.
So to power the educational kiosks and the future education center, the same Panasonic panels will be used. Currently, the site of the future center is in a densely forested area. To minimize any wildlife impact, the panels used will be placed along the fence perimeter of the wetlands, which is clear of any trees and gives easy access for maintenance. We're also proposing to include a floating solar display in one of the cells, which will educate visitors and provide the park staff a test model to see if the technology would work in it to power any future park facilities or even expanded gate automation.
The renewable energy requirements at 7 wetlands will vary slightly based on each individual control structure. The power requirements of the 4 automated gates of interest will be between 600 and 1,000 kilowatt hours per month. This varies on the current season. It is estimated that 30 solar panels will be needed to power the gates, totaling a cost of about $34,000. The monitoring equipment is estimated to cost about $14,000 with 12 solar panels installed adjacent to the automated control structures. The total cost of the education center was based on the floor plans of a building similar in size to a small elementary school. Finally, the educational kiosks are estimated to cost about $4,650.
Based on a cost estimate from a manufacturer we received, each control structure and gate will cost around $34,000 and $15,000 respectively. A base station, which will act as a point of control for all automation and data, costs around $15,000. For each gate, there will be an installation fee of about $2,500 and a design fee to design the control structure, gates. Any other equipment needed will cost about $30,000. We estimate the final cost to be around $337,000. With a cost to benefit ratio of 1.46, the cost saved on automated gate control and monitoring will enable the City of Lakeland to have a positive equivalent present worth. This basically means that they'll see a positive return on their initial investment in the standard 20-year service life of the control structures, gates, and renewable energy installations.
Allen Corps recognizes that the City of Lakeland is under limited budgetary constraints, and so we've identified 4 potential funding sources. The first funding source is the Clean Water State Revolving Fund, or CWSRF. The CWSRF is a collection of 20-year low-interest loans. These loans are granted to municipalities, just like the City of Lakeland, to upgrade wastewater projects, and Several Wetlands qualifies because of its function within the greater Polk County wastewater treatment system. The second source is the Tampa Bay Environmental Restoration Fund. This is an annual competitive grants program awarded to projects found in the Tampa Bay estuary watershed, of which Several Wetlands is included. A major funding source of this fund is the sale of Florida State Specialty License Plate, as depicted in the slide. The third funding source is the EPA Wetlands Program Development Fund. This fund awards projects that implement a sustainable monitoring program through the use of water data, which will be collected with the monitoring equipment. Finally, the fourth source is the Southwest Florida Water Management District, or SWIFMUD, Capital Improvement Plan. The Capital Improvement Plan awards projects that support water quality monitoring and data collection, which, as previously discussed, is a significant component of this project.
With that, our presentation is concluded. On behalf of Allie and Kra, thank you so much for listening today.